Solar, it's good to be back again and thank you. Welcome back to back, front to front. So sa ngayon mga ka-solar, ang nagtatanong sa atin na isang scientist, gusto niyang i-reverse charge yung battery niya from the inverter. At ipapakita ko sa inyo yung design niya which is really true and I'm convinced that it will really work. Okay mga ka-solar, yan ang ating pag-usapan ngayon. So stay tuned and sub likes. So here we go mga ka-solar. So before we start mga ka-solar sa ating pag-usapang design ng isang unlimited power inverter, let's go from the basic the basic operation principle of a solar energy. Okay, if you have the panel, the controller, and the battery, so it means mga ka-solar, basically yung solar charge controller mo will take far power from your solar panel and then i-charge na yung battery. Okay? That is the regular process and it happens every day during a daytime situation. Daytime condition. They call it daytime charging from your solar panel to the controller and charged to your battery. So this is the basic principle of a solar charging operation. So ang likot ng isip niya mga ka-solar, no? Mga loads, ang likot. Kasi sa gabi daw, gusto niyang i-charge ang kanyang battery sa ganitong sistema. And here we go. During the night time, considering wala nang gamit yung ating controller at yung ating solar panel because no more power is came in from them, no? So you only have during the night time the battery, the inverter, and gusto niyang lagyan ng isang battery charger. And look what is claiming to mga ka-solar. So from the battery, susuplayan niya yung inverter. And then, it goes that the supply from your battery going to your inverter ay isusupply na naman niya, mga loads, doon sa kanyang battery charger. Then from that inverter going to your battery charger, which is 220 volts going to your 12 volts, yung battery charger, ay i-charge naman niya yung battery mo from your battery charger. And this design, ay tuwang-tuwa siya mga ka-solar, no? Mga loads. Kasi sabi niya, ito ay unlimited power. It's pure free energy yung tawag niya. The cycle of all the power and kilowatt from your battery going to the inverter, going to your charger, and this is a free energy. Di ba? Ang ganda mga ka-solar, no? Ang ganda ng kanyang design and super ganda. And it's pwede nang i-fit sa mga Tesla cars and the Tesla grids. So, ganito. Before we go to the deep analysis, ganitong system, is it possible? Actually, mga ka-solar, possible ito. Theoretically, possible. But the question is, how long? Anong epekto nito if you connect the system in this condition and this situation? Diba? So, let's dig down deeper, mga loads. So, considering ito ay isang 24 volts na battery, then, syempre, if-feed niya ito to your inverter. And then, she will convert your 12 volts DC to AC. 220 volts AC. Okay? So, this conversion factor, so conversion pa lang dito mga kalods, this already compromises a power loss. So, from that 12 volts going to 220, mayroon ng tinatawag yung losses, the power loss, which is consumed by the inverter, and they call it the residual power. And then going also to your inverter, to your charger, kasi step down naman niya yung to 12 volts, yung 220, exist din dito yung residual power consumption ng iyong battery charger, which is considered as a power loss. Diba? May losses na yan, mga ka-solar. And then to explain more about losses, bakit may losses ba? Bakit may residual power ba yung inverter mo at yung charger? Actually, mga ka-solar, no? The power loss, the power loss going to your charger, to your battery, this happens during the conversion process from 12 volts to 220 and then 220 to 12 volts. So, ganito. In layman's term, mga lods, no, we will basically analyze the condition. No? Considering meron tayong 100 watts output from your battery. So, yung 100 watts power na yan, if you feed niya yan to your inverter. Okay? And then eventually, pagdating niya sa inverter, that 100 watts ay magle-lessen na yan into 95 watts because of the losses. So, may 5 watts ka na consume from your inverter. This is considered as the residual power. And then from that 95 watts going to your charger, which is going in, at lalabas na yan ng into 85 watts. And then, more of the powers consumed doon sa battery charger mo. And eventually, yung i-charge mo to your battery is less than 85 watts. By the way, residual power losses or losses are losses which are consumed to your electronic devices, which is considered into the electricity is converted into heat or consumed by the transformer or the inductance or the capacitance stored in the electronic components of your inverters and chargers. So that is considered of the losses during the conversion factor, or they considered as the efficiency, mga lods. Power input over the power output, or power output over the input. So, from 100 watts cycle, ang papasok na lang sa battery mo, babalik is only around 75 watts. And the rest was consumed with all of the appliances of your devices. So, considering, mga loads, ito yung curve mo, but on and on, during the cycle period, the power that you released and feedback to your battery is losing. So, liliit ng liliit ang iyong power. So, that is the cases if you are going to design this kind of a system. So, this system is really a failure because nag-aaksaya ka lang ng yung iniisip, which is damaging to your system. At kahit walang load, even though walang load, you just keep the system charging and losing its power. So, this is the most convenient way to charge your battery, mga ka-solar. So, charge it from the daytime, from panel to controller to your battery, and then the nighttime, just use solely your battery power. So, yan, mga ka-solar. So, kung ayaw mong maniwala, ba't di mo subukan, ano? I try it and try. Mas maganda yung magiging scientist tayo sa bandang muli. Tayo rin ang matututo because failure will make us learn and grow. So, thank you, mga ka-solar, and see you again. See you in the next video.